Welcome to this lecture of the course Digital Electronics and Circuits, and in this particular lecture we will be quickly talking through to another important combinational circuits called multiplexer and demultiplexer. Let's begin by a multiplexer circuit, and a multiplexer circuit is something which we call as 2 raised to power n is to 1 multiplexer, and the meaning of that would be clear to you in such a small time, right? When we it's represented in a shorthand notation as mux, we call it multiplexer, and it's usually termed as 2 raised to power n is to 1 multiplexer. So basically kinds of multiplexer could be 2 is to 1, 4 is to 1, 8 is to 1, so on and so forth, right? So multiplexer is a circuit such that we have an output Q, and we have set of, say, we are looking at 2 is to 1, right? Let's assume we have set of two inputs D1 and D0. Depending upon the select lines, one of these inputs will be transferred to the output. So basically, if S is equal to 0, my output Q would be equal to D0. If S is equal to 1, Q will be equal to D1. And since we have already written too many equations right now, I don't think we need to write a truth table for this again. Directly looking at this relation, we can say output Q is equal to S bar into D0 plus S into D1. Right? So depending upon whether what's the value of S, one of this input will be transferred to output. And basically, if we are looking at this, this is nothing but sum of products, right? This is sum of two products, and this could be realized using Boolean gates. We can have set of AND gates, NOT gate, and a OR gate. So basically, what we will have two AND gates, one NOT gate, and one OR gate to realize this circuit. This is just a multiplier circuit, and this is a MSP thing which we saw. Now basically we can have a variation of this multiplexer circuit where we say that output Q is not valid till the time enable signal is 0. So basically what we can do is we can add a enable port over here, and if enable is equal to 0, Q is equal to 0, else if enable is equal to 1, Q is equal to S bar dot D0 plus ST1, right? So basically Q, we can simply say Q is equal to enable into SD0 plus ST1, right? This is a situation where we have an enable input. Similarly, what we can do is we can look at another variation of a multiplexer where we have set of 4 is to 1 multiplexer. What we would have in this particular case is we will have set of 4 inputs and a set of two select lines S1, S0 and S1, and we have 4 bit input T3, T2, T1, D0, and depending upon the select lines, one of these inputs will be connected to this output line Q, right? So basically if S1 and S0 both are 0, my output Q will be equal to D0. If we have combination like 0 1, D1 will be the output, combination of 1 0, D2 would be the output, combination of 1 D3 would be the output. This simply means my Q is equal to S1 bar dot S0 bar into D plus S1 bar into S0 D1 plus S1 into S0 bar into D2 plus S1 into S0 into D3. So this will be the output Q. This is pretty simple, right? So multiplexer is one such example where we can switch or we can route one of the multiple inputs to one outputs depending upon the select lines. Correct. Similarly, we have a variation of a multiplexer and something called as a demux, which is like opposite of what a multiplexer does. A demultiplexer is nothing. It's a logic circuit that transfers information on a single line onto one of the 2 raised to power n lines. So basically, if we talk about demux, right, demultiplexer, it's a logic circuit that will transfer information on one line to 2 raised to power n lines, and the selection of output line would depend upon value of the n select lines. So basically a demux is something like, let's assume we have 1 is to 2 demux, right? So basically we will have two outputs over here, q0 q1, and we will have one input line and one select line. This is like select 0, this is like D0, and depending upon value of the select line, whether it's a 0 or 1, this particular input over here would be transferred to Q0 and Q0 or Q1. This is similar to what we saw earlier in case of decoders, right? So basically what we can say is a decoder with an enable input can function like a demultiplexer. So this is one of the examples. Similarly, like we have 1:2 demux, we can have 1:4 demux as well. But in 1:4 demux, what we will have is we will have set of one input, set of two select lines, and then we have set of four outputs, similar to what a decoder does. I hope this lecture was clear. This was like we spoke about muxes and demultiplexers. Stay tuned for next set of lectures. Thank you.